Okay, so since a lot of you were on that field trip, well, a few of you were on the field trip in this class yesterday, you have to pay attention to this do now, because yesterday we went over the properties. Did anyone watch the video that wasn't here? Okay, all right. Oh, you didn't get ahead. Okay. All right, so I have a do now where we're working on the properties of the definite integral. So remember we used that number line technique? You liked it, right? Okay, so let's see what you get. Go through the whole thing, see what you get, and then I'm going to ask people, we'll see if anybody comes up with the same answer. And I'm just going to check the homework for people that were here. All right, Ryan got 8. Anyone get something different? You got 8? Ryan got 8. What'd you get? 0. Anything else so far? We have 8 and 0. Any other answers? No? All right, so hopefully it's 8 or 0. All right, let's see. All right, for people that weren't here, this is how we do this type of problem. We call it the number line technique. Makes it so nice. So you draw a number line. Now, how do you know what numbers to mark? What do you use? Yes, Cameron. Yeah, the limits of integration. So what numbers did you mark it off at? 1, 2, 5, and 7. Right? And then you fill in the values of the definite integrals, but you can only fill in the values if the lower limit of integration is less than the upper limit of integration. Everything has to work left to right. So are there any here of the given definite integral values that you cannot use? Gina? Yeah. So you can't use the 4. So you can switch them, right? So one of the properties of the definite integral says, okay, you can switch them, but do you get the same answer? There you go. So we'll be able to use the negative 4. Okay, so let's fill in the values then. Okay, so the definite integral from 1 to 2 is 3. Is that? Yeah, if you switch the limits of integration, you're subtracting in the opposite order after you get the antiderivative, and so you're going to get the opposite answer. So, yeah, if they give you the definite integral from 7 to 5, you can't use that one. You have to use definite integral from 5 to 7. If we're going to use the number line technique, everything has to work left to right on the number line. So we fill in the 3 from 1 to 2, 1 to 5. So from 1 to 5, it's negative 1. And so one of the properties of definite integrals is you can just add them. It's like the sum of the parts equals the whole. So just from those two, what do we know the definite integral has to be from 2 to 5? Negative 4, right? Because 3 plus negative 4 equals negative 1. Now then we also figured out the definite integral from 5 to, that's supposed to be a 7, is negative 4. So we'll fill that in. 5 to 7 is negative 4. This one, this one? Oh, because if you go all the way from 1 to 5, that definite integral is negative 1. From 1 to 2 is 3. So you have to ask yourself, 3 plus what will equal negative 1? Because remember when you break it up? Okay. Yes, exactly. So when you're given definite integrals, just make sure the lower limit of integration is less than the upper one. If not, switch them and negate the value. All right, so then looking at this, if I were to just ask you for the definite integral from 2 to 7, so from 2 to 7, what would you get? From 2 to 7 in that order? Negative 8, right? It'd be negative 4 plus negative 4. But they asked us for the definite integral from 7 to 2, so it's positive 8. Got it? So this answer, the one we're looking for, is positive 8. Because it's from 7 to 2. Kind of fun, right? Not bad. All right, let's see how the homework went. Can you see that? Is that large enough for you to see back there? Yeah. So check off your answers. Got mine. We'll go over a couple of these. Think about the ones you want to go over. Oh, you know. Going over number 8. Sorry, kids. Yeah, so the definite integral from -1 to 1 is the definite integral from -1 to 0 plus the definite integral from 0 to 1. See that's how we could break it up? See, now it's clear what to put in for h of x in each one of these cases. For the first integral, the x values are going from -1 to 0, so they're negative. If x is a negative value, this is what h of x equals, -2x. We put that in there for h of x. In the second definite integral, the x values are going from 0 to 1. They're positive. If x is positive, we put 1 minus x in for h of x. So yeah, that's something to think about. That's when breaking up a definite integral into the sum of two others is very nice. When you have to find the definite integral of a piecewise function that's changing at some point within the interval. So you break it up, you put in the values, and then it's just a normal, you have to evaluate both of these. You actually have to multiply it out. Just put that up there. And after we multiply it out, we have to take the antiderivative. And we're going to plug in the upper, the lower, and subtract. So let me just put that up there so you can see it. Can I scroll up a little more? Or do you need to see the top line? Or you just broke it up? That's good. So you really have two definite integrals you got to evaluate here. Fine. Is that clear? Do you need more explanation? That one, bless you. All right. So what? Any other questions? I'm sure there are a lot of them. 6? And Amanda, what are you going to say? 3? Let's see what 3 is. Ah, yeah. Let's look at 3, and then I'll go to 6. So in number 3, they tell you got this function, and f of -x equals f of x. Remember in pre-calc, we were constantly bugging you with, hey, is this function odd, even, or neither? It's because of this. If f of -x equals f of x, can you tell me if this is odd or even? Even. And if a function is even, tell me about the symmetry. What's the symmetry? The y-axis. See, it doesn't matter whether you plug in 3 or -3. You're going to get the same y coordinate, right? But they're saying that f of -x is equal to f of x. So whether you plug in a 2 or a -2, you get the same y. And if you do that for every single point, see it's symmetric about the y-axis? Yeah, so when f of -x equals f of x, it's even, and that's how we remember it, and symmetric about the y-axis. Okay, so they're telling you I have an even function, and I'll just draw anything even. Let's draw out the y-axis. And they ask us, number 3, then which of the following is true? And they talk about the definite integral from -a to +a. remember the definite integral, and I'll put a positive function in here, is just the area, right? Area under the graph if it's a positive function. So the definite integral from negative a to a, would that equal the definite integral from negative a to 0? No. What would you have to do to get the definite integral from negative a to a? Yeah. Yeah, you can multiply either of these by 2, right? Or add them together. And so if you look at choice E, it says the definite integral from negative a to a would be 2 times the definite integral from 0 to a. The whole thing is twice half of it. Oh, wow. You didn't like the even function. Okay. 6 is a real AP problem. So let's take a look at 6, because I heard that one. I have that one on here, I think. Maybe not. Okay. They give you the value, number 6, the definite integral of g of x is 3b minus a. I just tell you that. But then they say, okay, so what's the value of the definite integral of g of x minus 7? What are we allowed to do when we take the definite integral of a sum or a difference? Break them up, take it separately, right? That's what we do. So we just break it up. Now, this first one, they told us. We don't care if it looks weird. They gave us that one. That's 3b minus a. The second one we have to do ourselves. So to take the antiderivative of 7, okay, that's just 7x. And we have to evaluate that from a to b. And we plug in the upper and the lower and we subtract. So this term, they've already evaluated the definite integral. It's 3b minus a. But the 7, we had to actually get the antiderivative, plug in the upper, the lower, subtract, and we have 7b minus 7a. And when we subtract it, we get 6a minus 4b. Cool? All right, I got to go to the lesson so we can do it. You ready to do this? First one on there. Oh. Okay. I don't know if we did this one together. I don't think we did this. Did we? Definite integral of sine? I think we took the definite integral of cosine x from 0 to pi over 2. Yeah. Okay, so let's just do this one by hand with the fundamental theorem of calculus. Go ahead and get an answer for that. Let me see what you get. Jenna, you zoning? Did you do it? You already did it? Yeah. Oh, you have the answer ready? Oh, wait, let me just give him 1 minute. Riley, are you okay? Yeah, you're looking at your paper too closely again. You done already too? Sorry. All right. Raise your hand if you already have an answer. Who's going to tell me the antiderivative of sine x? Be so careful. This, yeah? Negative cosine x. Lovely. We're evaluating from 0 to 2 pi. Okay, what are you going to pop in there first? The 2 pi. So we need the negative cosine of 2 pi minus negative the cosine of 0. Let's go visit the unit circle. 0. They both coterminal over there. All right, cosine of, if I just asked you for cosine of 2 pi, what's that? Cosine, is it the x or the y coordinate? It's the x, right? Cosine sine, alphabetic order. Okay, so the cosine of 2 pi is 1. So we have negative cosine of 2 pi, negative 1, minus negative, so plus the cosine of 0, 1. So what do we get? 0. Remember when I said as long as your function is positive, the definite integral, that number you get is the area under the graph? Sine x from 0 to 2 pi, is that always positive? No. Can you show me with your hands what that graph looks like from 0 to 2 pi, sine of x from 0 to 2 pi? Okay. Sine x, you guys remember that one, right? Starts at 0, goes up, down, and back. There's the sine of x. So it's definitely not always positive from 0 to 2 pi. We got an answer of 0. So that's not the total area, yes, Ryan? Yes, actually, that's true. It's when you get an answer for a definite integral, if the function's not positive all the time, what it's really giving you, in fact, it's always giving you, the area enclosed by the graph in the x-axis above the x-axis, oh, I should have done that one in green, but then minus the area below the x-axis. So you can get an answer of 0 if you have the same area above as you do below. So that's why we're getting 0. So, in your own words, explain what the definite integral tells you. You need to write something to that effect. The area above minus the area below the x-axis. But you got to be clear, because you're going to get an answer. You want to know what it represents. Remember that. Oh, I don't want that one. All right. Sorry. This is what I want. Okay, I want to change the problem up a little bit. Now I want to find the definite integral from 0 to 2 pi of the absolute value of sine x. Go ahead, use your calculators this time. Math 9. I guess I should hook mine up. Make sure you're in radian mode in this class. You guys know where the absolute value is, right? Where is it again? Oh, you do catalog? Yeah. Okay. You can go to math number, too. So we want, and we got to be in radian mode. Mode. Close the absolute value. When you use the calculator to evaluate a definite integral, you use the math 9, the function integrate. You put in the function, then what? Comma x, okay. Comma lower, comma upper. Very good. All right. What did I write? Oh, it should be from 0 to 2 pi. I must have moved it by mistake. Thanks. Yes, tell me what you get. You got 4? No, 4? Yeah. Now I want you to think about what's going on now. We put the absolute value around a function. What does that do to the graph? What are you going to say, Gina? Now it's only positive. So do we have any area below the x-axis? Nope. This is the quickest way to find the area enclosed by a graph in the x-axis. If you don't just want area above minus area below, you want that total area. Back to this. Think about what putting absolute values around the function does to the function. You got your normal y equals the sine of x. Okay, positive and negative. But if you want the total area enclosed by the graph and the x-axis, you don't want to just take the definite integral. Because that's going to give you area above minus area below. Tell me about the graph of the absolute value of sine x when sine x is positive. What's it going to look like? If sine x is positive, like from 0 to pi, what's the absolute value of sine x going to look like? It's going to be different or the same? Same, right? So the graph of the absolute value of sine x looks the exact same as the graph of sine x, right? From 0 to pi. But now, for values of x between pi and 2 pi, sine x is negative. Where's the graph of the absolute value of sine x going to be? Above it, right? It's going to flip it up here. So the graph is going to be what I have here in green. This is the graph of y equals the absolute value of sine x. So if you take the absolute value of a function first, then take the definite integral, now you're just getting all this area, which is the total area enclosed by the graph and the x-axis. That's a nice little trick. And I'll tell you, that's the thing to do when you're allowed to use a calculator. So as far as explain what the definite integral of the absolute value of a function tells you, what does it give you again? Okay. Total area. Total area enclosed by the graph and the x-axis. Riley? It's supposed to be 2 pi. Wait, when you had your calculator? Oh, you wanted to do the other way? With the other graph? Well, you have to first, to use the calc menu, you have to first graph it. So you want to see the absolute value of sine x and get the definite integral that way? Okay, so you go to y equals. You have to put in the absolute value of sine x. Math. Now you need a nice window. You want to use a Zoom 7? Yeah, Zoom 7's nice. Zoom 7. Okay. See, here's a graph of the absolute value of sine x. Now we want to get the definite integral from 0 to 2 pi using the calc menu, using the graph. Second, calc, option 7. Lower, I press 0, enter. Upper, oh, am I going to be 2 pi? If it's not in the window, oh, that's the error. Because I must be slightly, I thought that window went from negative 2 pi to 2 pi. So to fix that, we can go back to the window. Oops, go to. Let me just go back to the, get out of this thing. Let's just make the x max slightly greater, because for some reason it doesn't realize that 2 pi is in that window. It thinks we've gone outside the window. It doesn't want us to do that. And I'll just make this 7. All right. I'll look at the graph again. Now, if I try that, calc 7, lower 0, enter, upper 2 pi, enter, it does it, and it gives me 4. Yeah, it really should. Yeah, you know, I think it's, I guess it was just too close. It's got to be inside the window to use that feature. So neat. Okay. Okay, so if any time you want to find a total enclosed area between a graph and the x-axis, just put some absolute values around the function, then take the definite integral. What if we don't have a calculator? Well, that one we got to think it through. Now, your homework tonight is going to be to finish whatever examples we don't finish today. We're going to start C. Let's see where it goes. But we're not using calculators at all here, okay? Find the area enclosed between the curve y equals some cubic and the x-axis. You guys are pretty good with polynomials, right? All right, we're not going to go to our calculator to see what it looks like. Do we know what cubics look like in general? Nice. You guys, you know cubics? So we're going to sketch it. Now, we want to get the area enclosed by the graph and the x-axis. What do I need to find? Well, before we can do that, like as far as what I need to know from the graph, I want to get the area enclosed by the graph and the x-axis. Say it again. Where it crosses. How do you find where a graph crosses the x-axis? Set the y equal to 0. Okay. Then if we set y equal to 0, how are we going to solve for x? We can factor out an x. We're going to factor. Can we factor that anymore? Okay. So we can factor as x minus 2. What'd you say the other one was? X plus 1. Yeah, we write it as a product because products equal 0 and any of the factors equal 0. So what are our zeros going to be? 0, 2, and negative 1. All right, so I got these 3 points. These are the only points that really matter. I mean, we know what the shape of the graph looks like. 0, 2, negative 1. Now, before I sketch something in, I have to know about the end behavior. I want to know, is it going up to the right or is it going down to the right? As the x-coordinates approach infinity, are the y's going to positive infinity or negative infinity? We used to talk about end behavior last year, what the graph looked like. Look at this. Look at the leading term. Show me what you think it's doing to the right with your hand. Upside down. Guys, any idea? If you look at the leading term, if it's positive, it's going to go up, right? As the x is go to positive infinity, think about that. These terms don't even matter, all right? X positive infinity to the cube, that'd go up to positive infinity. So when I want to graph it, it doesn't matter how low or high you go. You just want to get an idea of what this thing looks like. It's going up. And we know it's crossing and it's going down. That's good enough. Now, we want to get the total enclosed area between this graph and the x-axis. We want this area plus this one. If I just take the definite integral from negative 1 to 2, am I going to get this area plus that area? What does the definite integral give me? The difference, it's going to give me this area minus that area. I don't want that. Okay, yeah, if I had a calculator, I'd put some absolute values on it. You're right. But let's say I don't have a calculator. Okay, Riley, what are you going to say to that? Well, we did flip that part, but we did take the absolute value, which flipped the part where it was negative, and that was great. And you can put absolute values on it. That's wonderful. Wait, Ellie? Yeah, I think that sounds like a good idea. So let's take this in pieces, and I like that she's talking about them separately. So what about if I take the definite integral from negative 1 to 0? Will that give me that area? Yeah, because it's positive. So we all agree if we want to get the area of this first region, we could take the definite integral from negative 1 to 0 of x cubed minus x squared minus 2x. Okay, so that'll be great. 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 Now, she was saying, can you just find the definite integral of the second one here and make it positive? Okay. How can I write that? Because I know if I take the definite integral from 0 to 2, what kind of a number is it going to give me? A negative, right? Jeannie, got an idea? Ooh, you could switch the limits of integration and say plus the definite integral from 2 to 0. That's great. You want to do it that way? Or what else could you do? Opposite value. You could just subtract the definite integral from 0 to 2. What do you guys like better? Subtracting the definite integral from 0 to 2 or adding the definite integral from 2 to 0? They're the same. Oh, you like the adding. Okay. So what we'll do in here, if we want total area, wherever the graph is negative, we'll just switch the limits of integration. That was a good idea. Wow, this is going to be a lot of work. Is it? No. And I really want you to use the fundamental theorem of calculus to get this answer. Like if at the end, when you're done with this, if you want to just put in your calculator, math 9, the absolute value of that from -1 to 2, just check if you're right, you can. But do it all by hand here. Get the antiderivative, upper or lower, subtract for each one of them. Just put a subtraction. Sort it up. Just go to the summary. We'll just fill this in, and then you'll fill out those for homework. Okay, so when you find the definite integral from a to b of f of x, it's the area enclosed between the graph of y equals f of x and the x-axis, that is, what goes in here? So it's the area above the x-axis. I'm already figuring. Definite integral is the area above the x-axis. What goes in here? What do you do with the area? You start with the area above the x-axis, and then you subtract, so minus that which is below the x-axis. Good. To find the total area enclosed by the graph of the function, the x-axis, what can you do if you have a calculator? You can just find the definite integral from a to b of the absolute value of the function. Oh, wait. If you have a calculator, if not, you got to break it up. And we'll just say using that. Just say break it up. You can finish it there. All right, thanks, guys. So just finish those problems.